Can a machine think? This question has shaped science, philosophy, and our very idea of what it means to be human. It's not just about wires and code, it's about consciousness, creativity, and the nature of mind itself. This question sparked the birth of artificial intelligence, driving decades of research, breakthroughs, and even failures. Our dream isn't just to build tools, but to create partners, entities that might one day see the universe in ways we can't. The journey to AI is as much about understanding ourselves as it is about building technology. Long before computers, we imagined intelligent statues and mechanical beings in myths and legends. These stories reveal a deep human fascination with creating life from the inanimate. From clay golems to androids in science fiction, the idea of artificial minds has always captivated us. Now, as the line between human thought and machine calculation blurs, this ancient question is more urgent than ever. It's no longer just a story. It's a reality unfolding in labs, boardrooms, and homes worldwide. The answers we find will shape the future of humanity in ways we're only beginning to imagine. So let's explore how this question became the foundation of artificial intelligence. Artificial intelligence is no longer a distant dream, it's woven into our daily lives. AI listens to your questions, curates your social feeds, recommends products, and filters your email. It helps doctors diagnose, guides self-driving cars, and even composes music and art. We've invited AI into our homes, workplaces, and pockets, often without even noticing. But how did we get here? How did ancient myths become today's reality? The journey is a saga of brilliant minds, bold ideas, and moments that changed history. There were golden ages of optimism and harsh AI winters of disappointment. We'll meet pioneers like Ada Lovelace and Alan Turing, who first asked if machines could think. We'll see the birth of the first AI programs and the rise of deep learning. The history of AI is the story of a dream made real, one that continues to evolve. Let's travel back to where it all began. The dream of artificial intelligence is now part of our world. Before circuits, humanity dreamed of artificial life in myths and legends. The Greeks told of Hephaestus, who forged golden automatons, mechanical servants that could walk and talk. Talos, a giant bronze guardian, patrolled Crete, programmed for protection but vulnerable to a single flaw. These stories weren't just entertainment, they explored the boundaries between creator and creation. They asked, can a made being have purpose? Can it be controlled? Other cultures shared this fascination. In ancient China, Yuan Shi built a lifelike automaton that could sing and dance, blurring the line between illusion and reality. These tales reveal an early recognition of both the promise and peril of artificial beings. They weren't just tools, they were characters raising questions about free will and responsibility. The dream of perfect mimicry echoes in our quest for human-like AI today. Myths gave us the first blueprints for artificial minds. They set the stage for the real machines to come. The fascination with creating life from the lifeless is as old as humanity itself, and it's a dream we're still chasing. In Jewish folklore, the golem, a being of clay brought to life by sacred words, embodied the dream of creation and the danger of losing control. The golem was a protector, but its literal obedience made it unpredictable and sometimes dangerous. This theme, creation and control, runs through the history of artificial intelligence. The master craftsman appears again in history. Heron of Alexandria, a real engineer, built automatic doors, wine dispensers, and programmable carts. Heron's inventions were the first steps from myth to mechanical reality. Both mythical and real inventors shared the same ambition to breathe life or its illusion into the inanimate. Whether through sacred words or clever engineering, the goal was the same. These stories and inventions are the roots of robotics and AI. They remind us that every creation carries risk and responsibility. The desire to animate the lifeless is a powerful force in human history. It's the first step on the long road to artificial intelligence, and it's a journey that continues today. Ancient myths about artificial life are more than stories, they're a mirror of our deepest fascinations. The dream of AI isn't new, it's a fundamental part of being human. It springs from our curiosity about consciousness and our place in the universe. To build an artificial mind is to confront what makes us human: reason, emotion, creativity, empathy. The quest for AI is a journey of self-discovery as much as invention. The hopes and fears in ancient tales, servants, rebels, perfect mimics are the same themes we debate today. We've swapped gods and magic for algorithms and code, but the core questions remain. As we move from myth to machine, it's vital to remember these roots. The history of AI began with stories, sculptures, and poems, not computers. The dream of shaping inert matter into a thinking being is ancient. It's the cultural bedrock of modern AI. and it's a question we're still trying to answer. Turning myth into machine required a new language, one that could translate human logic for a device. This leap began in the 1800s with Ada Lovelace, a visionary who saw poetry in mathematics. Working with Charles Babbage on the analytical engine, Ada imagined a machine that could do more than calculate. She realized numbers could represent anything, music, letters, art, and that a machine could manipulate symbols, not just numbers. Ada wrote the world's first computer program, a step-by-step algorithm for the analytical engine. She saw that a machine's power lay in its instructions, its software. Ada was the first to grasp that computers could be general purpose, limited only by our creativity. Though Babbage's machine was never built in their lifetimes, Ada's ideas planted the seed for modern computing. Her vision lay dormant for decades, waiting for technology to catch up. Ada Lovelace is the prophet of the digital age. She showed that machines could be more than tools. They could be creative partners. Her insight is the philosophical foundation of computer science. The age of artificial intelligence began with her imagination. Amidst the backdrop of war, Alan Turing, a brilliant mathematician and codebreaker, reignited Ada Lovelace's vision. He dared to ask, "Can a machine truly think?" Turing reframed this philosophical question into the Turing test. If a judge can't distinguish between a machine and a human in a text conversation, the machine is deemed to be thinking. At Bletchley Park, Turing designed machines to crack the Enigma code. He formalized the concept of a universal computing machine, the foundation of every computer today. Turing connected Lovelace's vision to modern technology, providing the foundation for the digital revolution and the birth of AI. The theories of Lovelace and Turing were elegant and powerful, but they needed a physical form. The end of World War II unleashed a torrent of innovation, as the technologies developed for the war effort were repurposed for new, peaceful applications. Scientists and engineers, armed with new knowledge of electronics, began the race to build the first real, programmable, electronic computers. These were not the sleek devices we know today. They were colossal machines, behemoths that filled entire rooms built with thousands of fragile, glowing vacuum tubes and miles of tangled wires. They were incredibly slow and unreliable by our standards. One of the first of these giants was the ENIAC, the Electronic Numerical Integrator and Computer, completed in 1946. It was a monster, weighing over 30 tons and consuming enough electricity to power a small town. Programming it was a grueling physical task that involved manually rewiring connections and flipping thousands of switches, a process that could take days. Yet for all its limitations, ENIAC was a miracle. It could perform calculations 1,000 times faster than any human, solving in hours problems that would have taken mathematicians years. It proved that large-scale electronic computing was not just possible, but a reality. These early machines were primarily built for number crunching, calculating artillery firing tables, modeling atomic reactions, or performing census calculations. The idea that they could be used for something like intelligence was still on the fringes, but the potential was there, humming away in their electronic hearts. With the hardware finally in place, the stage was set for the next great leap. The question was no longer if we could build a machine that computes, but what we could make it compute. The focus began to shift from pure calculation to something more ambitious: simulation. The birth of the computer was the essential final piece of the puzzle. It was the missing link between the ancient dream of automatons and the modern quest for artificial intelligence. For the first time in history, the thinkers, the dreamers, and the philosophers had a tool, a universal machine, capable of testing their ideas. The theoretical groundwork laid by Lovelace and Turing could now be explored in practice. The age of myth was over. The age of computer science had begun. With the first computers humming, the time was ripe to christen a new field. In the summer of '56, scientists gathered at Dartmouth College. This legendary brainstorming session marked the birth of artificial intelligence. The term was coined by John McCarthy, deliberately bold and ambitious. They believed any aspect of intelligence could be precisely described so a machine could simulate it. This declaration set the agenda for decades. The conference aimed to advance language processing, abstraction, problem-solving, and self-improvement. It brought together key thinkers and established AI as a legitimate field. It created a community and a roadmap. The conference sparked excitement and funding. From this meeting, the first AI researchers emerged, setting up AI labs at MIT and Carnegie Mellon. They believed intelligence was information processing. The computer was the perfect tool to bring an artificial mind into existence. In the years following the Dartmouth Conference, the field of AI exploded. This period is often called the first golden age of AI. Early researchers began to produce astonishing results that captured the public's imagination, creating programs that could perform tasks previously thought to be the exclusive domain of human intellect. One of the most famous early programs was The Logic Theorist, created by Alan Newell and Herbert A. Simon, designed to prove mathematical theorems. This demonstrated that a machine could do more than just calculate, it could reason. This success was followed by the General Problem Solver, designed to, in theory, solve any formalized problem. Researchers also taught machines to play games. Arthur Samuel, an AI pioneer at IBM, created a checkers program that could learn from its own mistakes and beat a respectable human amateur. These early programs generated a huge amount of excitement and media attention. The work attracted significant funding, particularly from government agencies like DARPA, who saw the immense potential of intelligent machines for military applications. While some researchers were building intelligent minds in software, others aimed to give those minds a physical body. The dream of the automaton was being reborn in the laboratories. The goal, robots that could perceive, move, and interact with the physical world. This required solving incredibly difficult problems. A robot needed to see, understand, and translate that understanding into physical actions. One iconic project was Shaky the Robot, developed at the Stanford Research Institute. Shaky could navigate a room, perceiving objects and planning actions to achieve a goal. Shaky was a landmark achievement, the first mobile robot to reason about its actions. The work on Shaky laid the foundation for everything from Mars rovers to self-driving cars. However, it also revealed how immensely difficult these real-world tasks were, presenting challenges that pioneers had underestimated. After the dazzling successes of the first golden age, the sense of optimism surrounding AI was almost boundless. The public and funding agencies had been captivated by this vision of the future. But as the 1960s gave way to the 1970s, a sense of unease began to creep in. The promises that had seemed just around the corner began to recede into a distant, hazy future. The core of the problem was complexity, but the real world was infinitely more messy, ambiguous, and unpredictable. It was a fundamentally harder problem than they had ever imagined, a phenomenon known as the combinatorial explosion. The dream of general-purpose intelligence remained elusive. AI lacked a body of common sense. This growing list of unfulfilled promises began to create a credibility problem. The boundless optimism of the golden age was beginning to look like naivety. The once bright summer of AI was about to give way to a long and bitter winter. Doubts about AI's progress boiled over in the mid-1970s. In the UK, this skepticism was formalized with the release of the Lighthill Report. The report was a devastating critique declaring that AI had failed to achieve its objectives. The report was scathing, concluding that machines would never achieve human-level intelligence. The report was influential, giving politicians the justification to make drastic cuts. Government funding for AI research was almost completely eliminated in the UK and significantly reduced in the US. This loss of funding sent a chilling effect throughout the AI community. Graduate students were advised to pursue other fields, and researchers rebranded AI to avoid the stigma. The first AI winter had officially begun. The AI winter was not a complete stop, but rather a long, quiet season of consolidation and introspection. With funding scarce and public interest at a low, the field turned inward. The grand, all-encompassing visions of creating a human-like mind were put on hold. Instead, researchers who remained focused on narrower, more practical problems. This period, while difficult, was not without its own kind of progress. It forced a necessary dose of realism upon the community. The focus shifted from trying to build a thinking machine all at once, to developing specific tools that could solve real-world problems. One area that blossomed during this time was the development of expert systems. These were a more modest form of AI. Instead of trying to replicate general human intelligence, expert systems aimed to capture knowledge in very specific domains, like diagnosing diseases or identifying oil exploration sites. They were built on if-then rules extracted from human specialists. These systems were successful because their scope was tightly limited. They didn't need common sense, they just needed a comprehensive rulebook for their particular task. They demonstrated that AI could deliver real commercial value, keeping the flame of the field from being extinguished entirely. However, even the success of expert systems eventually led to another smaller winter in the late 80s. These systems were expensive, difficult to maintain, and brittle. They would fail spectacularly outside their narrow expertise. The market collapsed, and AI became associated with hype and disappointment once again. This second dip reinforced the lessons of the first winter. The challenges of intelligence were far deeper than pioneers had suspected. The old approach of hand-coding knowledge was hitting a fundamental limit. A new approach was desperately needed. This long, quiet season was a humbling but essential period. It culled unrealistic hype and forced researchers to confront true difficulty. The winters cleared away less promising paths, leaving ground fertile for new ideas to take root. The researchers who persevered were a hardy bunch, driven by deep belief in their field's potential. They kept working in the background, quietly laying groundwork for the next revolution. They didn't know it yet, but a new spring was on the horizon, powered by an old idea about to get a second chance. After the long AI winters, the field needed a new source of warmth. That idea was the neural network, inspired by the human brain. Early pioneers developed simple versions, but they couldn't solve complex problems. This contributed to the first AI winter. But some researchers kept the faith, envisioning deep neural networks. These networks could learn complex, hierarchical representations. This approach, known as deep learning, was plagued by a lack of data and slow computers. The revolution had to wait. In the 2000s, the internet created an explosion of data. Powerful GPUs were developed, perfectly suited for training deep neural networks. All the pieces were finally on the board. The AI winter was about to end. The year 2012 was the moment the thaw turned into a flood. It was the year of the ImageNet Large-Scale Visual Recognition Challenge, an annual competition to see which computer program was best at identifying objects in a massive dataset. But in 2012, a team from the University of Toronto entered a deep neural network named AlexNet. What happened next sent shockwaves through the entire field of computer science and technology. It annihilated the competition. It was a quantum leap forward. It was a stunning, unambiguous victory for the deep learning approach. The success of AlexNet was the starting gun for the modern AI revolution. Suddenly, the floodgates opened. This period was like a Cambrian explosion for artificial intelligence. New species of AI applications were evolving at a breathtaking pace. The next great milestone came in 2016, in a 5-game match of Go, a game AI experts believed was too complex for computers to master. The champion, Lee Sedol, faced AlphaGo, a deep learning system from Google's DeepMind. AlphaGo won, 4-1, making creative and unexpected moves. AlphaGo discovered new strategies beyond human knowledge, combining deep neural networks with reinforcement learning. AlphaGo's victory marked a new era of flexible learning AI, tackling intelligence at its core and reshaping our understanding of it. So, here we are. We have journeyed from the myths of ancient Greece to the triumph of AlphaGo. We have seen a dream born in poetry and philosophy become a tangible, powerful force that is actively reshaping our world. The history of artificial intelligence is no longer just a history, it is our present reality. The deep learning revolution, born from an old idea supercharged with data and processing power, has broken out of the laboratory. It is now a fundamental utility. It is the silent, intelligent layer that underpins so much of our modern lives. This intelligence is present in the recommendation engines that suggest what we should watch, read, or buy next, subtly shaping our culture and our choices. It's in the navigation apps that analyze traffic in real time to find us the quickest route. It's helping scientists accelerate the discovery of new medicines. But in doing so, we have also opened a Pandora's box of new profound questions. As these systems become more autonomous and more integrated into the fabric of society, we must grapple with enormous ethical challenges. The power of this technology is immense, and with that power comes an equally immense responsibility. We are the generation that must navigate this new landscape. The story of AI has brought us to this incredible peak of achievement. The journey is far from over. As we stand here today, it is tempting to think we are at the end of this story. If the history of artificial intelligence were a book, we have only just finished the preface. The explosive progress we have witnessed is the beginning of a new, accelerated era. The next chapters will be about the quest for artificial general intelligence, or AGI. These are the questions that will define the 21st century, challenging our place in the universe. It holds the promise of solving some of humanity's most pressing problems, but it also brings profound risks that we must manage with wisdom. It has always been, and will always be, a story about us. And now, the future is in our hands. The story of AI is just beginning and we are all its authors.